90%. That is the number of surveyed developers who are actually using AI at work right now.
That's a massive number.
Yeah, it's huge. But here is the really wild part. A shocking number of their companies are actually losing productivity because of it.
Which nobody really talks about.
Right. So today we're finding out why that is, and more importantly, how to fix it. Welcome to this custom-tailored deep dive into the June 1st through 15th, 2026 edition of the Google Cloud Platform Technology Nuggets. We are so thrilled you're joining us.
Absolutely.
Yeah, and our mission today is really looking past the marketing hype, you know? We want to uncover the gritty, practical reality of building and scaling AI on Google Cloud Platform, or GCP.
Yeah, because this isn't about, theoretical AI magic.
Exactly. This discussion is designed specifically for you, the beginner to intermediate practitioner who really wants to know how these systems actually function under the hood.
Yeah, because the marketing brochures, they always present AI as this magic switch.
Oh, for sure.
You turn it on, and immediately your entire organization is faster, leaner, and just perfectly optimized.
Which would be nice.
Right. But the reality on the ground for engineering teams is just vastly different. And the latest DevOps Research and Assessment report, the DORA report, actually captures this friction perfectly.
Yeah, because that 90% adoption rate among developers is massive. You'd think with that kind of saturation, every software company would be reporting, I don't know, record-breaking development cycles.
You would think so, yeah.
But the report highlights a very real market divide, right? The actual financial returns are just lagging way behind the adoption.
They really are. And early adoption of generative AI and software engineering, it almost universally triggers what the industry is calling the J-curve of AI value realization.
Wait, a J-curve?
Yeah, so if you visualize a letter J on a graph, the line representing productivity actually dips significantly below your starting baseline first.
Oh, wow.
Yeah, it dips down before it ever curves upward into that exponential growth we all want. Organizations experience a very tangible period where things get noticeably worse.
Worse as in, slower.
Slower, less stable, more frustrating. All of that before they get better.
That is wild. Wait, so you give a developer an ultra-smart AI assistant that's, capable of writing hundreds of lines of code in seconds, and the immediate result is that the entire team slows down?
Exactly.
I mean, the math on that feels incredibly counterintuitive.
It does, but it's because the bottleneck shifts.
Right.
Generating the code becomes nearly instantaneous, sure. But code generation is only one fraction of the software lifecycle.
Right.
First, there's the human learning curve. Developers have to actually learn how to prompt these models effectively.
Which is basically a totally new cognitive skill.
Exactly. It takes time. And second, your downstream pipeline, so things like automated testing, security scanning, QA review, those were built for human speed output.
Oh, I see.
Yeah, suddenly those pipelines are just overwhelmed by a massive volume of machine-generated code. But really, the heaviest anchor pulling that J-curve downward is the verification tax.
The verification tax. It's like hiring a brilliant but incredibly reckless intern.
That's a great way to put it.
Right. They can draft a complex 30-page technical spec for you in 5 minutes, which sounds amazing.
Sure.
But from experience, they have a tendency to completely fabricate statistics or invent API endpoints that don't even exist.
Yes, exactly.
So you end up spending more time meticulously double-checking their work for these hallucinations than you would have spent just writing the document yourself.
That is the verification tax right there.
Yeah.
You are shifting the developer's role from creator to auditor.
Ah, yeah.
And reviewing generated code to ensure it's secure, performant, and actually grounded in your company's reality. That takes intense focus. Until an engineering culture optimizes its workflows around that specific auditing process, productivity just tanks.
So to pull ourselves out of that J-curve dip, we really have to stop the AI from hallucinating in the first place.
Precisely.
And the only way to do that is to give it access to a company's specific internal context, right?
Yeah, because AI models, they're trained on the public internet. They know absolutely nothing about your proprietary database schemas or your internal metric definitions.
Or your incident response runbooks.
Right. And in most enterprises, that internal knowledge is just severely fragmented. It's scattered across a dozen different siloed systems.
Well, Google Cloud is actually addressing this fragmentation directly with their new data formatting solution. They just introduced the Open Knowledge Format, or OKF version 0.1.
Yeah, and OKF is a vendor-neutral specification. It's really aiming to standardize how metadata and context are structured.
Okay.
The whole goal is to make internal company knowledge readable for both AI agents and human engineers simultaneously.
What really stands out to me about it is how lightweight it is. Like, OKF doesn't require learning some complex new querying language.
No, not at all.
It just organizes your internal knowledge as a simple directory of standard Markdown files. But then it adds YAML front matter at the top of those files.
Exactly.
You just define a type field in the YAML, and the system uses standard Markdown links to build a relational graph of your internal information.
And the practitioner benefit there is enormous. You are building a highly structured knowledge graph without needing to deploy custom runtimes or integrate complex SDKs.
That's so nice.
Yeah, it relies on formatting standards developers already use every single day.
Okay, so OKF handles the structured internal knowledge beautifully. But enterprises also generate mountains of messy, unstructured data.
Oh, definitely.
And for that, we turn to Google Cloud Storage. Just to give a quick overview for those newer to the ecosystem, Google Cloud Storage, or GCS, is GCP's highly scalable object storage service.
Right.
You can think of it as the foundational dumping ground where companies store vast amounts of unstructured data. We're talking petabytes of images, application logs, raw text files, things like that.
And historically, if you wanted an AI model to actually read and utilize that passive data just sitting in GCS, you were staring down weeks of custom integration plumbing.
Yeah.
You had to write scripts to extract the data, format it, pipe it into the model's context window. It was a mess. But now GCS natively supports the Model Context Protocol, or MCP.
Which is awesome. MCP essentially acts as a universal translator, right, between your data sources and your AI agents.
Precisely. By supporting MCP natively, GCS turns all of that passive enterprise storage into active agent-ready context.
Wow.
The custom plumbing is just eliminated. You can utilize the remote MCP server hosted directly by Google or run the open source version locally.
The Tech Nuggets actually shared a fantastic real-world example of this with Snap.
Oh yeah, that was a great case study.
Yeah, they deployed an MCP server agent to analyze historical system metrics that were just sitting dormant in GCS. And by giving the AI direct, structured access to that unstructured data, they cut their job investigation time from 30 minutes down to just 30 seconds.
It's incredible. And that time reduction, that is how you escape the verification tax.
Right.
The AI isn't guessing anymore. It's instantly referencing the actual historical logs. So it's providing accurate, grounded context that the human engineer can immediately trust.
So once the data is organized and accessible through OKF and MCP, we cross the threshold into actually doing something with it. We enter the agentic era.
Yes, we do.
We are building conversational agents that act on our behalf.
And the Agentic Data Cloud updates really reveal Google's strategy here.
Yeah.
They are embedding these conversational analytics directly into the interfaces where people already work.
Yeah, we see this expanding heavily into BigQuery and Looker. And just as a quick practitioner refresher, BigQuery is GCP's fully managed enterprise data warehouse.
Right, exactly.
It's the massive engine you use to run SQL queries across petabytes of data. And then Looker is GCP's business intelligence platform used to create visualizations and dashboards from that data.
So the preview of Looker dashboard agents fundamentally changes how non-technical users interact with that data.
Right, because instead of a business user having to submit a ticket to the data engineering team because, they don't know how to write a complex SQL join, they can just type a natural language question directly into the Looker dashboard.
Exactly.
They can just ask, show me the correlation between ad spend and user retention in the Midwest for Q3, and the agent just builds the visualization on the fly.
It's so powerful. And we're also seeing these agents gain deep access to operational databases. Like Google just made the fully managed remote MCP server for AlloyDB generally available.
Okay, AlloyDB.
Yeah, and for context, AlloyDB is GCP's fully managed PostgreSQL compatible database. It's engineered specifically for high-demand, top-tier enterprise workloads.
Honestly, giving an autonomous AI agent direct access to a top-tier production database sounds terrifying.
Oh, absolutely.
Like, I immediately picture an agent misinterpreting a prompt and just dropping the primary customer table, wiping out the entire business.
Yeah, and that's why security by design is paramount when building these agentic systems. Google anticipated that exact nightmare scenario.
Thank goodness.
Yeah, they engineered a read-only SQL execution tool directly into the remote MCP server for AlloyDB.
Okay, so the agent physically lacks the capability to destroy data?
Correct. The agent can read schemas, it can execute complex queries to fetch data, manage instances, even create backups. But the tool explicitly blocks any destructive data modification commands.
That is a relief.
Right. You get the analytical power of the agent without the existential risk to your production data. Plus, every single action it takes is recorded in cloud audit logs for compliance.
That makes a lot of sense. So we've covered querying data, but developers are also using these agents to actively build and migrate applications, right?
Yes, definitely.
And Google's agentic platform, which is called Anti-Gravity, is really pushing the boundaries here. The platform encompasses Anti-Gravity 2.0, a dedicated IDE, a command line interface, and an SDK.
Yeah, and the Tech Nuggets detailed a very practical use case for this. They talked about migrating away from NPM dependency overhead, which, is a notorious pain point for Node.js developers.
Oh, for sure. A team utilized the anti-gravity cell CLI tool to migrate a heavy, resource-intensive Node.js runtime over to a compiled, lightweight Go binary.
Right.
And what really fascinates me here is the division of labor. The human engineers established the architectural goals, and they audited the final logic. But anti-gravity handled all the mechanical grunt work.
Yeah, it performed the line-by-line code translation, but it went way further than that. It autonomously generated the unit tests for the new Go code to ensure parity with the old Node application.
That saves so much time.
And it also handled the path mapping.
Which is huge, because path mapping is usually where migrations just completely fall apart.
Oh, 100%.
The AI had to rewrite all the internal file references, update the routing logic, and make sure the new Go binary actually talked to the rest of the existing system using the correct directories.
Yeah.
It basically did all the tedious wiring that humans hate doing.
It did. And this highlights a profound shift in how advanced engineering teams are actually interacting with AI. Well, they are moving past using the AI as just an eager, polite assistant that simply generates whatever you ask it to. They are deploying it as an adversarial thinker.
I really love this concept. Like, imagine you write a complex script to query a database and process user transactions.
Yep.
Instead of asking the AI to write the code for you, you hand it your finished code and prompt it to act like a pedantic, highly critical security auditor.
Yes.
You ask it to actively hunt for edge cases or to find race conditions where two users might try to buy the same item at the exact same millisecond. You tell it to intentionally break your logic.
Exactly. You are harnessing the model's massive pattern recognition capabilities to stress test your human assumptions before that code ever reaches production.
Which is brilliant.
It really is. This adversarial prompting is the ultimate tool for accelerating out of that J-curve.
Okay, so we've built these brilliant adversarial agents, but an enterprise agent can't just live on your laptop.
No, definitely not.
The moment 10,000 users ask it a question at the same time, it's going to crash unless it has a highly scalable home.
Right. And for deploying and orchestrating these agentic workloads securely, the industry standard is Google Kubernetes Engine, or GKE.
Okay.
And for those listening, GKE is GCP's managed environment for deploying, managing, and scaling containerized applications.
But hosting AI on Kubernetes introduces a very specific and honestly very expensive problem, doesn't it?
It does.
Because traffic for conversational agents is wildly spiky. Users ask a question, they read the answer for a minute, and then they ask another.
Right.
If you constantly over-provision your GKE clusters to handle those sudden spikes, you are just burning through your infrastructure budget.
Oh, absolutely.
But if you rely on standard Kubernetes autoscaling, the nodes take too long to boot up. Your users are left staring at a spinning loading wheel while the AI wakes up from a cold start.
Exactly. And Google addressed this directly with the new GKE standby buffers feature. It provides pre-provisioned suspended capacity.
Wait, suspended capacity? Does that mean GKE is essentially taking a snapshot of the node's brain, writing it to a hard drive, and putting the hardware to sleep?
That is precisely the mechanism, yeah. GKE initializes the node completely. It starts the Kubernetes daemon sets, it preloads those massive container images, gets everything running.
Okay.
Then it saves that fully initialized state to the persistent disk and completely releases the compute and memory resources back to the cloud.
Wow, and the financial impact of that has to be huge.
It is.
Because you aren't paying hourly rates for expensive CPUs or RAM while the system is hibernating. You are only paying for the cheap, persistent disk storage and the reserved IP addresses.
Exactly.
And then when a traffic spike hits, the nodes wake up almost instantly from that disk state, bypassing the cold start entirely.
It is such an elegant solution to the cold start problem. But, keeping the nodes awake is only part of the battle.
What's the other part?
Well, large language models process information in a way that makes traditional load balancing highly inefficient. And we see this addressed with the new GKE inference gateway.
Right, because a traditional load balancer just uses a round-robin method, sending the next incoming request to whichever pod happens to be free. Why is that bad for an LLM?
Think about a multi-turn chat application. A user has a long, ongoing conversation with an agent.
Okay.
Every time they ask a follow-up question, the entire history of that conversation is sent back to the model as part of the prompt so the AI remembers the context.
Oh, right.
If a round-robin load balancer sends that fifth question to a completely random pod, that new pod has to process the entire conversation history from scratch before it can even answer the new question.
Oh, wow. It's like forcing the AI to reread the entire book every single time you ask a question about the final chapter.
Exactly.
It's a massive waste of processing power.
It is. And the GKE inference gateway solves this using model-aware routing and something called prefix caching.
How does that work?
It routes the incoming request to the specific pod that previously handled that user's conversation. That pod already has the mathematical weight, the activation state of those previous prompt segments, stored directly in its key value cache memory.
Oh, I see. So it remembers the context mechanically in its RAM, so it only has to process the new text.
Exactly.
And the Tech Nuggets noted that Snap Inc. used this exact setup with the open source LMD framework, and they hit prefix cache hit rates of up to 80%.
Huge.
They literally eliminated 80% of the redundant processing work.
The reduction in latency and compute costs is just staggering. But, performance optimizations only really matter if the system stays online.
Good point.
If a physical cloud region experiences an outage, your global agents need to fail over instantly.
And GCP detailed a really robust high-availability architecture for this. They use multi-cluster, cross-region internal application load balancers to route global traffic seamlessly between GKE clusters that are sitting in entirely different geographic regions.
And the hardware routing behind that is fascinating. They are using GKE-managed Dranet.
Dranet.
Yep, because standard networking fabrics simply choke on the massive volume of data passed between AI chips. Dranet provides the dedicated accelerator networking required to handle the fire hose of traffic moving through the massive TPU v6e node pools.
And just to clarify, those TPU v6e node pools are Google's custom-built, highly specialized AI processing chips.
Right.
They also highlighted the use of cloud storage FUSE, which is a brilliant mechanism.
It really is.
Instead of a new pod spinning up and having to download terabytes of Gemma 3 model weights from a storage bucket before it can even start working, UC allows the pod to mount that storage bucket directly as if it were a local file system.
Yeah.
The pod just accesses the weights instantly wherever it spins up globally.
You are looking at a masterclass in global stateful workload orchestration.
Absolutely. So we have these incredibly fast, autonomous agents running globally, accessing our most sensitive enterprise data.
Yes.
The productivity gains are undeniable, but the security implications are pretty daunting.
Oh, without a doubt.
Because the speed of these agents means that if a malicious actor finds a vulnerability, the blast radius of the attack expands at machine speed.
Which means you have to fight automation with automation. This is the whole philosophy behind Google AI Threat Defense, which integrates directly into Google Security Operations, or CCOPS.
Okay.
For context, CCOPS is GCP's centralized platform for monitoring, detecting, and responding to enterprise cyber threats.
Right. And to combat AI-powered threats, they introduced 3 specialized Gemini native security agents.
Yeah.
First is the Detection Engineering Agent, which is currently in preview. It autonomously creates and validates custom URL detection rules. And URL is essentially a highly specialized pattern-matching language used by security researchers to identify malware and classify threats.
Exactly.
So the AI is writing these complex defense rules on the fly based on incoming threat intelligence.
Next is the Threat Hunting Agent, also in preview. And this one doesn't just wait for an alarm to go off.
What does it do?
It proactively scours your historical enterprise telemetry, looking for subtle behavioral patterns, not just obvious keywords, that indicate an attacker managed to bypass your initial perimeter controls, maybe weeks or months ago.
Wow. And finally, there's the triage and investigation agent, which is generally available. It autonomously reviews threat signals across cloud infrastructure, endpoints, network traffic, and identity logs.
And the speed is what matters there.
Yeah, it reduces the time it takes to analyze a complex security alert from 30 minutes down to just 60 seconds.
It fundamentally changes the operational tempo of a security operations center.
Mhm.
And to ensure platform administrators maintain strict oversight over these autonomous agents, Google introduced Activity Insights within Storage Insights datasets.
Which is really cool because this automatically generates a query-ready BigQuery index of your entire storage estate. You can track exactly how your unstructured data is being accessed or modified by these agents. You can monitor object-level actions and track regional traffic, like the volume of ingress and egress bytes moving out of a specific geographic region.
Which ensures the agents aren't quietly exfiltrating data.
Exactly. So you secure the software layer, you monitor the agents, but eventually you collide with physical reality.
Always.
Running massive LLMs on TPU v6e pools requires hardware, and that hardware generates an immense amount of heat.
Yeah, we are hitting the limits of thermodynamics here.
Yeah.
We're dealing with next-generation AI and high-performance computing chips that exceed 1,000 watts of thermal design power, or TDP.
1,000 watts.
Yeah, a single chip is generating enough localized heat to literally cook food.
That is insane. And standard air conditioning fans blowing through a traditional data center just cannot pull heat away from a 1,000-watt chip fast enough.
No, they fail completely.
Oh.
Historically, running advanced AI workloads required physically tearing apart your existing data center to install massive, facility-wide liquid cooling plumbing.
Which sounds like a logistical nightmare.
It is. It's incredibly expensive and disruptive.
This is exactly why the Brazos cooling system caught my eye. It solves that physical facility bottleneck. Brazos is a rack-mounted, closed-loop, liquid-to-air cooling system.
And the engineering is just brilliant in its modularity. It allows you to deploy high-density, liquid-cooled hardware directly inside an existing, older air-cooled data center without requiring any of those facility retrofits.
The mechanism is what makes it so practical. It completely separates the internal liquid loop from the building's water supply.
Right.
The liquid cooling happens in a closed loop contained entirely within the server rack itself. Cold liquid runs over those 1,000-watt chips, absorbs the massive heat, and then pumps that hot liquid to a highly efficient radiator at the back of the rack.
And then that radiator transfers the heat from the liquid directly into the data center's standard ambient airflow.
Oh, wow.
Yeah, so the facility's existing air conditioning handles the exhaust just like it would for a traditional server rack.
Yeah.
You simply roll the Brazos rack into your current server room, plug it in, and you are running liquid-cooled AI hardware.
That's like installing a high-end liquid-cooled radiator for a Formula One engine, but engineering it so it fits perfectly inside a standard suburban garage.
That is the perfect analogy. It is a phenomenal bridge between legacy facilities and next-generation compute.
Well, we have covered immense ground today. We confronted the J-curve, understanding why productivity initially dips, and how that verification tax really slows teams down.
We did.
But then we learned how to cure those hallucinations by grounding the AI with structured context via the open knowledge format and unstructured context using the Model Context Protocol on Google Cloud Storage.
And we explored the agentic era. We talked about utilizing Looker dashboard agents for natural language analytics and deploying anti-gravity as an adversarial thinker to automatically migrate applications and stress test our logic.
Then we tackled deployment, scaling efficiently on GKE with standby buffers to eliminate cold starts, and utilizing the inference gateway's prefix caching to slash LLM processing costs.
Right.
And finally, we secured the perimeter with Gemini native CCOPS agents and cooled that massive 1,000-watt hardware with the Brazos liquid-to-air system.
The entire stack is incredibly robust, yet looking at the Brazos system leaves us with a critical realization.
What's that?
Well, as an industry, we spend vast amounts of time optimizing the software layer. We write better prompts to reduce hallucination taxes, we refine our Yale rules, and we cache our prefixes to shave off milliseconds of compute time.
We really just focus on the code.
Right, but the ultimate bottleneck for the future of artificial intelligence will not be software. It'll be the inescapable physical limits of thermodynamics and the raw capacity of our electrical grid.
Wow.
So the question we must ask ourselves as practitioners is this. As we design and deploy these massive autonomous agentic systems, are we thinking critically enough about the physical real-world footprint of the code we write?
A sobering thought to mull over the next time you spin up a massive cluster. We encourage you to explore the original resources from this Tech Nuggets edition. Dive into the detailed anti-gravity guide to understand which CLI tools fit your specific migration scenario.
Absolutely.
And if you are building unique agentic solutions, consider sharing your architecture by writing for the Google Cloud Medium publication. Until next time, keep digging, keep questioning, and we'll see you on the next deep dive.